Now let's talk about how to find the area of irregular figures. There are multiple methods or ways to go about this process. Let's start with the first method. First step in this process is to divide the irregular figure into smaller figures that you know how to find the area of. For example, you might be dividing something into triangles or rectangles or trapezoids. Label each small figure and label the new lengths and widths of each shape. Then find the area of each shape, add up your areas, and label the answer. Let's take a look at some example problems and work through this process. Find the area of the figure. So the first step in this process is to divide or split this diagram into two smaller figures. So I see two rectangles, one on top and one on the bottom. We already know what the length and width are for the top rectangle, but this 8 meters is getting split up. So if I know that from here to here is 2 meters, then the remaining amount will be 6 meters, because 8 represents the entire thing. So now we have area 1 at the top and area 2 down low. So now let's find the area of each one. So the area of the first rectangle is found by multiplying 2 times 4. And when we do that, we'll get 8 square meters. And now let's do area 2. It's found by multiplying the length, which is 12, by the width, which is 6. And when we multiply those together, we get 72 square meters. And then if we add these two up for the total area, we will end up getting 72 plus 8, which is 80 square meters. And here we see again the work used to solve this example problem. Area of rectangle 1 was found by multiplying 4 times 2, which is 8 square meters. And area 2 was found by multiplying 12 and 6, which is 72 square meters. And if we add up 8 and 72, we get 80 square meters, which is the total area of our figure. If you remember, we had this question, or the area of this shaded region, earlier. Is there another way that we could calculate the area of this shape in a coordinate plane? There actually is. We could end up splitting this into two separate triangles. So if I was to draw a straight line like this, we split this quadrilateral into two triangles. And then we can also extend or draw in the heights of each one. They are perpendicular to this base each time. We can see that the heights are there. So let's label this one as area 1, and this triangle is area 2. And we have to count to find what the base length is and each height. So the base is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So the base is 18 units. The height in triangle 1 is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 units. So we can calculate the area of triangle 1 using 1/2 base, which is 18, and the height, which is 11. Half of 18 is 9, and 9 times 11 is 99 square units. And now we also have a second triangle, triangle 2. We know that its base already is 18 units because both triangle 1 and triangle 2 share that common base. So the area of triangle 2 is going to be 1/2. Its base is 18, and now we have to determine its height. 1, 2, 3, 4, 5, 6, 7. So height 2 is 7. And now if we multiply these together, 1/2 of 18 is 9. 9 times 7 is 63 square units. And that's the area of triangle 2. And then if we were to add these two areas up, we can get the total area of this shape. And again, we're adding them up. So we have 99 plus 63. And 9 plus 3 is 12. So we put the 2 down and we bring the 1 over into the tens column because it represents 10 plus 2. And then 10 plus 90 is 100. And 100 plus 60 is 160. So we have 162 square units as the area of this quadrilateral. And this is consistent with the area that we had found earlier. Now let's talk about another method to find the area of irregular figures. It is possible to create one large closed figure, such as a rectangle or a huge triangle that covers all of the area. And then label the small added figure and label the new lengths and widths of each shape. Find the area of the new large figure and also find the area of the smaller figure that you're going to have there, and then subtract those two areas. Label the final answer. Let's see how this looks in a few examples. Find the area of the figure. So the first step that we have here is we can see that this irregular figure can be composed of two rectangles, one that is a little bit bigger than the other. So here's the big rectangle that's coming there. And then we also have a smaller rectangle that we're going to subtract out, and it is right here. So we have these two areas that we need to find. First, we have the area of the big rectangle, and its length is 12 and its width is 8. So we're going to multiply 12 and 8, and when we do that, we get 96 square meters. And now we have this separate, smaller area. Its width is 2. Its length is actually 12 minus 4, which is 8 meters. So the area of the small rectangle is going to be found by multiplying 8 meters by 2 meters. And when we multiply them, we'll get 16 square meters. And then in order to calculate the area of the shaded region that is in bright green, we're going to subtract these two. So the area of the figure, or the area of this problem, is going to be 96 minus 16, which is 80 square meters. And if you'll recall, we did find that the area of this figure is indeed 80 square meters using a different method prior. As you can see, here again is the work done to find the area of our whole rectangle and the area of this extra rectangle that's not within the shaded region as 96 and 16, which is what we calculated. And then if we subtract those two, we do get the area of the shaded region, which is 80 square meters. Find the area of the figure. So we have this diagram, and it's made up of two rectangles, and they can be interpreted in two different ways, and both methods will be shown in this video. The first method is to slice off this part, and we have two rectangles. Here's one rectangle and here's the second one. And if we were to calculate the area of both of these and add them up, we would get the area of the figure that we have. So we have 3.2 meters and 5.6 meters as the length and width of rectangle 1. So if we multiply them together, we will get 17 and 92 hundredths of a meter, of a square meter. So that's area 1. Now area 2 would be multiplying 8.8 or 8 and 8/10 times 3 and 4/10 meters. And when we do that, we will get the value of 29 and 92 hundredths of a square meter. And then if we add up both of these areas to get the total, we would get 17 and 92 hundredths plus 29 and 92 hundredths. We would get 47 and 84 hundredths square meters as the total area. Now let's try to also get this area using a different method. So the other method for doing this is to consider that we have a whole rectangle and another section that we take out. So the entire length of the big rectangle is the same as the bottom, 8 and 8/10 meters. And now if we add up 3 and 4/10 of a meter and 5 and 6/10 meters, we would end up getting a total of 9 meters. So if we multiply to get now the area of the big rectangle, it would be 9 times 8 and 8/10, and that would give us 79 and 2/10 square meters. That's for the area of the big rectangle. And then if we subtract out the area of the smaller rectangle, we'll end up getting the area of this region over here. So we know one of the values for the small one, its length is 5.6, but then we have to subtract 8.8 and 3.2, and we end up getting 5 and 6/10. So that's this side length also, 5 and 6/10 meters. And if we multiply 5 and 6/10 by 5 and 6/10, we get 31 and 36 hundredths square meters. So to get the area of the figure, we are going to subtract these two values. So that's 79 and 2/10, has a 0 in the hundredths place, minus 31 and 36 hundredths. We end up getting the same value here. We still get 47 and 84 hundredths square meters using both methods. Find the area of the figure. What we have here is a regular pentagon. All of its sides are congruent, And the regular pentagon can be split into two shapes. First shape being the isosceles triangle, and the second shape being a trapezoid. We know how to find the area of both of those shapes. So let's start with the area of the triangle. Area of a triangle is 1/2 times its base, which is 19 4/10, times its height, which is 7. And if we multiply these together, we get an area of 67 9/10 square feet. Next, we have to calculate the area of our trapezoid. So the area of the trapezoid is found using the formula 1/2 times the height, which is 11 4/10, times the sum of its bases, which is 19 4/10 plus 12. And if we add up both of our bases, we get a sum of 31 4/10. And then we'll drop down the 1/2 and the 11 4/10 for the 1/2 and the height. And now if we multiply these three numbers together, we will get the area of the trapezoid, which is 178 98 square feet. And then to get the area of the entire pentagon, we're going to add both of these up. So area total is going to be 67 9/10 plus 178 98. And when we add these two numbers together, we will get a total area of 246 88 square feet.